Hello everyone, welcome to YashaswiTechHub. So we are going to start with the topic Diffie-Hellman and Key Exchange Algorithm from the Cryptography and Network Security. So we know that in asymmetric encryption we have two types of keys, public key and private key. This is a type of cryptographic protocol that allows two parties, that is A and B, to establish a secret key for communication over an insecure communication channel. Secret key is used for encryption of the messages. So the main idea of this algorithm is limited to the exchange of the secret values. Let us understand this Diffie-Hellman key exchange algorithm with an example of a numerical. So we have two parties, one is sender A and receiver B. The step 1 is to consider a prime number Q. So in real life they are going to take a very large number. Let us take the prime number Q equal to 7. In the second step, what we do is we are going to choose an alpha which will be lesser than Q. That is a number which is lesser than 7. And alpha must be a primitive root of Q. So what is a primitive root? So the primitive root is nothing but, so alpha mod Q, that is alpha is nothing but, we are going to consider 3 now. So 3 mod 7, 3 square mod 7, 3 cube mod 7, all these values must come in a set of 1, 2, 3 till Q minus 1. That is, we are going to have the values till 1 to 6 since we have the Q equal to 7. So we have got to know that the primitive root is nothing but 3 here for the 7. So there will be many primitive roots. So we are going to find our best one primitive root. So we have chosen Q equal to 7 and alpha equal to 3. So let us move on to the step 3 where we are going to calculate the public key of A. So in A side there are two types of keys we know. One is the private key of A and the other is public key of A. So XA represents the private key of A, YA represents the public key of A. So XA we are going to choose which must be lesser than Q. So here we have chosen XA equal to 5. XA can be any number, it can be any numerical, any integer. So XA we have chosen as 5. You can choose 2, 3, 4, 5, any numbers. Better take a positive number. So we have taken 5 lesser than 7. So then we are going to calculate the public key. The way we can calculate is YA equal to alpha to the power XA mod Q. Remember YA XA. Okay, so we are going to calculate by using the private key of A. So YA equal to 3 to the power 5 mod 7. Since we know that alpha equal to 3. So we have got the public key of A which is equal to 5. So we know the public key and the private key. We have got 5 and 5. Do you think it will be secure if we get both the public key and the private key as 5? No, na? So let us continue with the B. So when it comes to the B side, XA is private key of B and YA is public key of B. So similar way, YB we are going to calculate by using the private key of B and we have got the YB. So because unfortunately we have got YB as 4 which is similar to that of XA. So there's a little changes in the values which we must take. So let us start taking XB is equal to 6. So 6 is lesser than 7. So yes, so we start calculating with 3 to the power 6 which is XA equal to XB equal to 6 mod 7. We are going to get 1. So the next one is we are going to calculate the key. Always while calculating the key, K is equal to, we are going to use the public key of B. We are going to calculate key by using the public key of B and by using the private key of A, mod Q. So by putting all these values, we are going to get K equal to 1. So for B also, we are going to calculate the same way. You are going to use the public key of A with the power of XB, which is nothing but the private key of B, and we are going to get this. So the final thing is we must get KA and KB equal to 1. Then if both are same, then only the key shared is successful. So here's a small assignment, just comment it down. So try it out yourself. Just find if 5 is a primitive root of 7 And also take on A side, take alpha equal to 3, Q equal to 7. On B side, take alpha equal to 5 and Q equal to 7 and just comment it out whether the key is successful or unsuccessful. Okay, so this is a small question. So let us start solving it. So illustrate Diffie-Hellman key exchange and solve this problem. So they have given the XA, XB, alpha and Q values. So we are going to calculate the public key of A, public key of B. Then we are going to exchange the public keys, and by using this exchange public keys, we are going to calculate the key values. Since we got the same key value, so the key exchange is successful. So compute its public key. So we have got all these things and even the secret key, which is equal to 98. The key is successful. Just pause the video and try this question out yourself. Let us continue with the Diffie-Hellman algorithm. So we have two people, one is Alice and another one is Bob. So Alice is having a prime number Q and is having an integer alpha, and it is shared between Alice and Bob. Even Bob has the same Q and alpha. So then we are going to choose XA, which is the private key of A, which is lesser than Q. By using that XA, Alice is going to calculate the public key of A and is going to share it with the Bob. Similarly, Bob is going to calculate the public key of Bob and is going to share it with Alice. So since they have exchanged the public keys, they are going to calculate the keys. So we know that they are going to calculate the keys by using the public key of B, by which is raised to the power of private key of A. Similarly, this side it's the vice versa. So they are going to get the same key. So hence the key is successfully shared. So this is all about the Diffie-Hellman algorithm. So this is also has a threat here, which will be seeing. The threat is called as the man in the middle attack, which we'll be seeing in the next video. Stay tuned. Thank you.